So before making this video, I knew that Greek astronomy was, to put it kindly, inspired by Babylonian astronomy, but I didn't realize how much of an influence it had on modern astronomy. Really, a lot of concepts and research techniques that are still used today were developed in ancient Babylon. But the first thing we really need to get out of the way is the fact that in ancient cultures, astronomy and astrology were not separate things like they are in the modern era. The reason for this being that, being from so long before even the telescope was invented, there were really only a handful of reasons that somebody would actually want to track the night sky. Those mainly being navigation, the creation of calendars, and to track omens. And the Babylonians actually kind of did omens backwards to how everyone else did it. So instead of observing an omen and then deciding what was going to happen based on that omen, they would write down what they had observed, say if there had been a meteor shower or something, and then they would look later on at things that happened afterwards and come back to that initial observation and say what it had been a prediction for. And in doing this, they were able over time to develop the ability to predict beforehand easily predictable events. And they stored these in a special kind of, not a book because they were tablets, but like a book called the Enuma Anu Elil. And kind of one of the big ones was eclipses, because they occur fairly regularly and were one of the easier things to predict. And the big reason that they actually wanted to make these predictions in the first place is because it was kind of a fundamental belief of the culture that astronomical events were actually intentionally put there by the gods to be observed by humans so they could predict the future. So certain things ended up having certain specific interpretations associated with them over time, and for an eclipse it was the association of the gods being angry with the king. So what they would do is whenever they knew that an eclipse was coming, they would switch out the king with a fake king, and they would put that king just on the throne for that day, and they would make a nice self-fulfilling prophecy by ending the ceremony with killing the fake king. And we do actually have a lot of the documents that they kept, which we're going to come back to, but in terms of kind of how astronomers were actually implemented into society, we really only have Greek records remaining. We don't have any sort of first-hand Babylonian accounts. So Strabo of Marcia writes about the Babylonian astronomers. In Babylon, a settlement is set apart for the local philosophers, the Chaldeans as they are called, who are concerned mostly with astronomy, but some of these, who are not approved by the others, profess to be writers of horoscopes. There is also a tribe of Chaldeans and a territory inhabited by them in the neighbourhood of the Arabs and of the Persian Gulf, as it is called. There are also several tribes of the Chaldean astronomers. For example, there are some called the Orcae, others Persephone, and several others by different names, as though divided into different sects which hold to various different dogmas about the same subjects. And mathematicians make mentions of some of these men, as for example Kidanas, Naburianos, and Sudinas. So Strabo tells us that the Chaldeans, which was just the Greek name for these astronomers, all studied more or less the same thing, but there is a bit of variation depending on which city they lived in, and as is evidenced by the fact that he talks about the importance of their research to mathematicians, there's a lot of maths involved in what they're doing. So they recorded their research down in 3 different types of documents: star catalogues, astronomical diaries, and almanacs. So the star catalogues are the bit that varies by location, because different city-states put importance on different sets of stars, and so those stars could be used for predicting certain omens within that city-state, but they wouldn't have those associations within a different city-state. The astronomical diaries are really the bread and butter of the work of the Chaldeans. They're pretty much exactly what they sound like. Every single night they go out and make observations about the night sky. They record down the positions of the moon and of the planets, and they record any noteworthy events that they observe. So eclipses, obviously very important, meteor showers, anything that was out of the ordinary. And then they would keep that information written down. They would wait to see what events occurred, and then they would come back and they would determine what events were associated with those omens. But then we kind of have the flip side of what they were doing with all their research, and gathering it up and collecting it together and making it into almanacs eventually, which was to create calendars. As you might be aware, creating calendars was very difficult for every single ancient society, because there's kind of this need to manage the year by the Earth's position around the sun, because that governs the seasons, and that's kind of the major thing that they want to track, so that they can keep track of when harvests happen and things like that. But a year obviously is a very long chunk of time, and there's kind of this need to break it down, and pretty much everyone goes for breaking it down with lunar months, but lunar months don't even come close to fitting in perfectly to years, which is why in the modern Gregorian calendar, months are just standardized sets of time that don't change, and it's just every year this month is this number of days, and it doesn't change except for when we have a leap year, because your choices are basically to have a really complex system or to do that and not include the moon in your months at all. But what the Chaldeans managed to actually figure out with all their gathering the research and doing all of their maths and building this kind of profile of how everything works is that the difference between 235 months and 19 years was just 2 hours. And that sounds great, right? Because that means that every 12 sets of 19 years, or every 228 years, you get an extra 24 hours, so you have an extra day, and that should be it, right? 228 years, a leap day. But it doesn't really work like that. Our Gregorian calendar can work like that because it's basically set up so that a cycle of years and a year are the same length of time. But because the cycle of years for the Babylonians was 19 years, that meant that every 19 years the start of the year would be on the same day, but for the years in between it would move around, so they had to conduct a complex system of adding in months on specific years within the cycle so that they could adjust the position of New Year's Day to be as close as possible to the spring equinox. And they did actually update this sometime in the 4th century BC. They came up with a better system that was 76 years long, and the start of the year moved around a lot less in it, and it was obviously a lot easier for them to manage. And this calendar was so advanced and so accurate for its time that it ended up spreading to other cultures. As you recall from what Strabo said, the Chaldeans were spread out a bit. They weren't just in the heart of Babylon, they were out with Arabic people and other people. So even actually the modern Hebrew calendar is still based on this ancient Babylonian calendar. On top of having the cycle for years, they actually also had a cycle for eclipses, because they managed to figure out from all their gathering of data that there's actually a specific pattern that eclipses follow that repeats every 18 years and 11.3 days. So they were able to quite easily track this because they would just move along the cycle and see where they were, so they always knew if an eclipse was coming up. And the cycle actually worked for both lunar and solar eclipses. And as you probably need to figure out at this point, they were very good at tracking lunar months, but they were also good at tracking what's called an anomalistic month, which if you think about how the moon cycles around the earth, it travels along an eclipse and it's closest to the earth at one point, and an anomalistic cycle is the time it takes for the moon to, from its closest point, travel along the ellipse and then come back to that closest point again. And they originally had a system for this where they mapped out the speed that the moon was traveling at by just using two speeds to approximate the moon. So when it was traveling along the kind of longer parts of the ellipse, it would be traveling at a higher speed, and when it was kind of traveling along the more curved parts at each end, it would be traveling at a slower speed. And at some time in the late 5th century, they replaced this with System B, where the speed of the moon would change as a function over time. So it would change like a sinusoidal wave. This is really impressive, and it really speaks volumes for the quality and the accuracy of the measurements they were taking, because the size of the moon in the night sky only changes by about 11%. What's more, they actually also developed the notation of measuring out a circle by dividing it into 360 degrees and then having 16 minutes of arc between each degree. And this is obviously still used to this very day by astronomers to map out the position of stars and other objects in the night sky. And obviously 360 degrees is still the system that we most commonly use for measuring out circles. So it's really not an understatement to say that without the Chaldeans and their research and developments that they made, modern science really wouldn't be the same at all. And I hope you enjoyed today's video. I know it's different from what I normally do. I personally enjoyed making it a lot, and I do have plans to make more of these for other ancient cultures and their astronomy. Next week I'm going to be returning back to a regular astrophysics video, but as usual, in the meantime, I do have links in the description below if you would like to read more about the Chaldeans and how they worked. And of course, feel free to ask any questions you might have in the comments below. And I'll be seeing you next week. Bye!